In example 4, it says a study is done on the number of bacteria cells in a petri dish. Suppose that the population size, P of t, after t hours is given by the following exponential function. P of t equals 2500 times 0.86 raised to the t. In letter A, we want to find the initial population size. What I want to do before we decide that is I want you to take a look at our exponential growth and decay functions. So remember, we didn't use A, we used Y. So we have Y equals C times 1 plus R to the t. That's our exponential growth function. And decay function was Y equals C times 1 minus R to the t. And then what happens is we go and we simplify. We either add this number or subtract that number to get one number raised to that t. Well, if we look at our function that we have here, we have something very similar to these two functions. We have C, we have our growth factor, which is that 1 plus or 1 minus R raised to the t. If you recall, the C value is always our initial amount. So if we want to find the initial population size, that's going to be the initial amount, or that C value in our equation. So our initial amount in this problem would be 2,500 bacteria. Then in part B, it says, does the function represent growth or decay, and how do you know? Here's our growth factor, or our exponential growth model, and here's our exponential decay model. The important part is right in the parentheses here. In the growth model, we're taking 1 and we're adding something to it, which means this number, this base for t, is always going to be bigger than 1. In this one, we're taking 1 and we're subtracting that percent. So we're always going to have a number that's smaller than 1, but bigger than 0, being raised to that t. So in letter B, is it growth or decay? If we look at the base, it's 0.86, which is definitely smaller than 1, but bigger than 0. So we can say this represents decay because the base is less than 1 but greater than 0. And then finally, letter C says, by what percent does the population size change each hour? So what I need, since we're dealing with exponential decay, I need to know what R is. Well, I know what 1 minus R is. This whole number here is that 0.86. So I know that 1 minus R is equal to 0.86. And I need to know what that R value is. So I'm just now going to solve for R. To solve for R, the first thing I would do is subtract 1 from both sides. And if I do that, I get negative R equal to negative 0.14. Then I would divide both sides by negative 1. And I get R is equal to 0.14. And then what I'm going to do is I'm going to change that decimal back to a percent. Changing it to a percent is the same as multiplying by 100, or moving that decimal place to the right by 2. So I would get an answer that my population is changing by 14% each hour. If you have questions, let me know. Otherwise, I'd like you to pause it and do the try this. Unpause it when you're ready to check your answer. If you did the try this correctly, you should see for letter A that your initial population size is 440. It represents decay because the base is less than 1 but bigger than 0. And letter C, by what percent does it change each year? And that would be 28%. If you have any questions, let me know.